All right, today we're going to go over the activity where we did the mapping out of the 10 vectors. I'll zoom in here. So this is the activity that we did on Friday, October the 17th. We are taking 10 vectors that were in the plastic bag. So I'm going to take the 10 vectors, make sure that I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 in there. I'm going to take one of those out. So I have 10 vectors, and the order that I start this does not matter. That's the whole idea behind this activity, is to show that it does not matter what order you start, you're always going to end up in the same place. So I have my graph paper. I have north, so it's north, east, south, and west. And so let me zoom out a little bit. Let's make this where you can see this. This is going to be my north, east, south, and west. Each one of these blocks represents 1 centimeter, or is a 1 centimeter square, and so 1 centimeter is going to be equivalent to 1 meter. We're going to go ahead and say that. So 1 centimeter is 1 meter. Now, I'm going to just randomly just pick these, whatever the order was. I'm going to go ahead and take these. So the first one that I have is 3 meters east. So what I want to do is make sure that I'm going east, which is to my right. So 3 meters east. So I'm going to count 1, 2, 3, and that's where my first arrow goes. So 3 meters east. I'm going to pick another vector here. 3 meters west. So that says 3 meters west. So I'm going to go back 3 meters west. So 1, 2, 3. That puts me right back at the starting point. So you can see that if I have 3 meters east and west, they're basically going to cancel each other out, because I'm right back at the starting point here. The next one that I have is 7 meters south. So I'm here, so I'm going to go down 7 meters. So 1, 2, 3, 4, 5, 6, 7. So I'm going to draw my vector representing 7 meters south. So I'm going to pick my next, which is 2 meters north. So I'm going to go back 2 meters from where I am right now. So I'm here, so I'm going to go 1, 2. So now I'm at this point. I'm going to draw another one here. It's 2 meters east. So from this point, I'm going to go 2 east, or to the right. So 1, 2 from that point puts me right here. And I draw the next one, and it says 1 meter north. So from my position, head to tail, I'm going to go up 1. I draw the next one. It actually says 1 meter north. So I'm going to go up again 1 meter. So there's my next vector. And notice I'm using head to tail method. So I always put my next vector at the head end of the last arrow that I drew, or the last vector that I drew. So anyway, 1 meter west is what I have next. So make sure I'm going west, which is left, 1 meter. So that puts me right here. I draw the next one. It's 4 meters south. So 1, 2, 3, 4 puts me right here. And then I have the last one, which is 2 meters south. So I'm going to go 1, 2, and that puts me right here. I'm just going to kind of circle that, saying that that's where I ended up. So I started at this point, and I ended up at this point right here that I've circled. So I'm going to use a ruler. Sorry about that. I had to get a ruler. So I'm going to get a ruler, and I'm going to measure the displacement. I'm going to make my displacement, or in other words, the resultant vector, I'm going to draw it in blue. So from my starting point to my end point is that blue line right here. So this is my resultant. So I went this entire distance here. I went to the right, went back, went down, up, did a little circle, came back around, and I ended up here. So my displacement is how far I am from my starting point, or the distance that I am from my starting to my ending point. So this is displacement. My distance that I traveled is totally different. If I wanted to do that, I'd have to add up all of these to get distance. However, this is my displacement. So now I'm just going to take these 10 vectors and I'm just going to mix them up. Totally mix them up. Doesn't matter what the order is, and you're going to see that. So I'm just going to put these here, and I'm just going to draw random ones. So I'm going to start back from my original position, which was the star right here. So that's the starting point. I'm going to start from there. From there, I'm going to go 1 meter north. So I'm going to go up 1. I draw another one. 3 meters east. East is to the right, so 1, 2, 3. Here's my third. I need to go 1 meter west. So 1 meter west would be to the left. Back 1. I'm right here. Don't lose track of where you are. Don't lose track of where you are. This is 2 meters south, so I'm going to go down 1, 2. 2 meters south. I draw my next one and it says 2 meters north. So I went 2 meters south a second ago. Now I'm doing 2 meters north. So I'm going to go back up, and you can see that they are canceling themselves out, really. So I'm right back at this point. The next one says 2 meters east. So that's to the right. So 1, 2. So now I'm 2 meters east. Next one says 3 meters west. So I need to go 1, 2, 3 meters west. And I'm back here. So now 7 meters south. So 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7. There's my vector. It's kind of packed in here. But I'm right here at this point. Don't want to lose that. Draw next one, and it says 1 meter north. So I'm going to go back up. I'm at this point. And then my last one says 4 meters south. So I was at this. So 1, 2, 3, and 4. And you'll notice that I ended up exactly where I ended up last time. So my last path that I took in the orange led me to this point.